Hey everybody, Arcade Dog Bell and I welcome you back. This is part 3 in our series on how to build the FujiNet. In the previous episodes we've prepared the boards, we've put components on the boards, we've run it through a reflow oven. In this episode we are going to attach the LEDs on the back side of the board for the indicator lights, as well as the through-hole components on the other side, which would be the 3 switches along the top and then the power slide switch. Pretty simple process to do, all pretty much by hand with a soldering iron, and hope you enjoy it. Let me know what you think in the comments below. Okay, they're out of the oven, they've cooled off a little bit. I've checked for any components that may not have been properly attached. Found a couple little areas that we had to touch up, a couple of bridges on the USB controller. You know, it's a real tiny pin chip. Generally you find a little bit on there, sometimes on the transistor since it's so small. But these boards are good to go, at least to this stage. So the next thing we're going to do is we're going to mount the LEDs on the back of them. And there is 3 LEDs that go back here. The first one's a blue one, and a white one, and it's for the Wi-Fi, so it lets you know when you're connected to the Wi-Fi. Second one's a blue one, and it's Bluetooth, lets you know when Bluetooth is activated. And the last one is an orange one, and that's the SIO activity light, so it'll flash as SIO data is being transmitted back and forth. I don't use the pick and place for doing this, just because there's 3 of them and it would take more time to set up the pick and place than it is just to place the 3 LEDs. So we'll get started on those. Generally I do 3 or 4 of them at a time, just because it's nice to get this solder flowing at the correct rate and just get them all real quick. So I'm going to hit these with a little dab of solder paste on each of the contacts. We're going to do all 5 of these red boards, and then we'll place the LEDs and use the hot air to reflow these. Only takes a moment. I mean, there's just such a little tiny bit of solder on these. This is one of the most challenging parts, I thought, when I first started doing these by hand. I can't tell you how many of these little LEDs I shot across my workbench, and with these parts, these 0402 parts, if you shoot one out of the tweezers, generally you're not going to find it. They're really, really small. So it's good, if you're going to try building a FujiNet by hand, to have a few extra parts. You know, the very first one I built, when they first released the hardware, I bought enough parts to make, I think, 2 or 3 boards, and I really, really regretted that, because, you know, when you shoot a part or 2 and it's the only part you have, it kind of makes it difficult to finish the board. So we've got that one down. One thing I learned the hard way, these are labeled D1, D3, and D2. And to me that seems kind of counterintuitive. You would think it'd be 1, 2, and 3, or 1, 2, 3. You'd think they'd be in order. You wouldn't be 1, 3, 2. So I got to pay real close attention to what LED I place where. Nothing like, you know, getting it all done and turn it on and notice that you've got the wrong colors in there. And again, I pull out 5 of these LEDs. Put them on the board, and since they are a diode, they do have a polarity, and you've got to make sure you get that polarity correct, otherwise the diode is not going to work. And these little guys are, the marking for the polarity is so small. I've basically learned I need to flip it in my finger. I need to wipe off this tweezer. Flip it on my finger, put it on its back side so that I can see the polarity marker, and then gently turn it back over. I need to clean off these tweezers. Gently turn it back over, not to lose orientation, and put it down. And it's primarily just this white one that's the most difficult. It's a different kind than the other 2. It's really challenging to mount this thing because it's got strange little pads on the bottom of it. Okay, we got that one. So we get the polarity right, and then I place it on the board. And then go to the next one. polarity right, flip it on my finger, grab it on the tweezer, stick it in the solder paste. I think I've had too much coffee this morning. I'm kind of extra shaky. And it's kind of funny, you never really notice how much your hand shakes until you start working on components that are this small. And you realize, oh my gosh, you know, I do shake. I think we got some solder paste on the tweezer again. I always thought I had really steady hands. Making FujiNets has kind of showed to me that no, I don't have the steady hands that I used to have. So I'd like to do a special shout out and thanks to Moswell for doing the hardware design on this, even though I give him grief about using the smallest, almost the smallest components you can possibly use. He did an amazing job on this, on the hardware. And as I'm building these now, we're at the end of the year, and version 1.3 has just been released, so I've got a couple hundred version 1.3 PCBs on the way. So we can start building version 1.3 here early next year. Also working with Steve Boswell on a couple other designs. We're going to do a little miniature Atari 1030 modem version of this. I know a few people have asked about doing a drop-in board so that you can gut the actual Atari 1030 modem and put a FujiNet in its place. So I'm going to look into doing that. I don't know if it would be very cost-effective because I don't think it would be that popular. But I did order a 1030 modem off of eBay yesterday just so I could have one in hand and get the measurements on it, because the ones that Steve Boswell and I are working on are going to be miniature. They're going to be like the S-Drive Maxes, small versions of the device. So I figured, it'd be nice to have a real modem so we can get the actual dimensions off of it. You know, Steve does an amazing job on these cases and has done, you know, great job with the S-Drive Max cases he's designed. So I'm super excited to see what we can come up with a FujiNet Atari 1030. Call it a 1030F for FujiNet. But look for that too in the coming months. It's definitely something we're both excited about. And we're also talking about doing a FujiNet that is 100% internal, so you can put it internally into the computer. Don't have to have a device hanging off the back end of it, which I know some people have talked or asked about and thought that would be a nice option to have. So we're looking at doing that too. But I got a feeling FujiNets are going to be here for a while now. You know, they're gaining in popularity. People are starting to develop some pretty cool things with them. And I have a feeling the more that get out there and in the hands of you guys, the more cool things we're going to see being built. Let's see, that was D3, right? Yeah, so D2. You know, it's pretty amazing when you think 40 years ago or 41 years ago when the Atari 8-bit came out, that those computers would still be in use today, and now they'd be attached to the internet. Who would have thought? So shout out to Moswell. I know, you know, a few people helped him, and shout out to Thomas Cherryhone, who did a lot of the firmware for these little guys. You two guys made this possible. Like I said, I know there's a bunch of people that contributed to this project, tons of people, but Thomas and Moswell are the main guys behind it all. So good job, you guys. Looking forward to seeing what you come up with next. This is going to be hard to beat. You know, if you guys are watching this and can think of any cool things that should be developed for the Ataris that aren't, drop me a note. You know, I'd love to hear your ideas, and I can promise you that if it's something that we do go ahead and run with, that you will be rewarded for it. You know, I totally believe in rewarding the people that spend their time working on or developing these things. As without you guys, these wouldn't be possible. warm up the hot air, let that brink come up to temperature. I might set it at 400 degrees. And we turn the fan way down on this. I'm not gonna be able to see very much, but we just lightly go over in kind of a circular motion, as to not blow the LED off the side of the board. We want to get this solder melted and the LED to snap into position. And that one shifted back. And we don't want to overcook the LED either, because you can damage the component by applying too much heat too long to the component. But you can see this goes relatively quick. For the 1.3 boards, I did order the stencil to do the backside. I keep calling it the backside. This is actually the front side. But the LED side, there is still only the LEDs on this side, and then an optional reset switch that I won't be installing on mine because you don't really need it. We got a power switch, does the same thing. So I did get the stencil to do the LED side, but I don't know if I'm gonna do it or not. It's just, like I said, I think it's more work than it's worth. And this one needs a little nudge. This goes so quickly. But yeah, if you guys think of anything that... Whoa, that one really flipped. Think of anything that we could work on and develop for the community, please drop me a note. It's a private message. And if it's something that we do, I'll be glad to reward you for your ideas. Always looking for something to offer Atari users. And there's a lot of creative minds out there. So, love to hear your ideas. Working on a couple of new things for 2021. I'm excited about. You should hear about them pretty soon. But anything to help this community. I love this community. I've been a member of it since 1980. And, anything we can do. Okay, and that is it. Those are the LEDs mounted on the front side of the FujiNet. We've got those 5 done. That's it for that side. Okay, next we're going to do the through-hole components, and there's not very many. There's the 3 switches along the top and the power switch. There's also a JTAG header that I put on mine, and then the SIO plug-in receptacles. But first we're going to do the switches, and then once we do the switches we can flash the firmware and make sure that it flashes okay, and if not, solve any problems before we go on to the next step. So we're going to do the switches now, and then we'll move on to flashing the firmware. So for this, we get the regular soldering iron out and put the 3 switches, A, B, and C, up here in the top. And then the power switch goes here, bend it over, and then I take a piece of tape, frog tape, since that's what I got laying around. It sticks pretty well, but not too much. And attach our switches, and then we'll go and solder them all. Kind of do like production line assembly here. But after dealing with those little tiny surface mount components, you kind of appreciate doing through-hole soldering. Through-hole soldering I just really enjoy. I actually volunteered to build a guy's MZ8080 kit because there's, it's about 6-7 hours worth of soldering on there, and I just enjoy soldering it so much. I built mine and said, oh, that was fun. I wish I had another one to build. And somebody said, well, if you want to build mine, I'll send it to you. So a guy sent me his, and I ended up doing all the soldering for him and then sending it back to him. I know it's weird, but I really enjoy doing through-hole soldering. It's just something about it. It's enjoyable to me. We just use the tape on that one because there's nothing that holds the power switch in, and I want to make sure it stays in the right place when we're connecting it. I'm super excited. The FujiNet 1.3's power switch has been replaced, and it's a substantial improvement over this little flimsy, weak thing that we're using on these. So that's a big plus for the new FujiNet. Super excited. Start building those here in the next few days. Let's get this. There's actually a couple of things we need to solder. We've got to solder this switch, and then we're going to need to solder the USB connector back here. If we don't solder that, it won't last very long, and you'll be pushing in the USB connector, and the little USB connector will just pop right off the board because it's only held on by 5 very small connections on the other side. So if you don't solder these on, you're gonna have a problem. And the funny thing with this too is you could put too much solder on it and it actually flows into the USB connection and makes it impossible for you to hook up the cable to it. So the USB through-hole solder is a bit of a learning curve to get it correct. But you don't want to forget it. Trust me, do not forget that. And then I make sure these switches are all still in the right place, and I'll just go solder one side of them. That way I know they're all positioned correctly. Make sure they didn't move, and they didn't. You know, I'd much rather find out that it shifted after doing one connection than find out it shifted after doing all of them, and I've got to get my desoldering tool out and desolder the switch and then resolder the switch. I like to check as I go, just to make sure. But simple. That one has all of its switches attached. We'll do one more, and then we'll move over to doing our flash test. Like I said, I learned the hard way. You know, if you build the entire board and then go to test it, and if you have a problem, you really don't know where the problem presented itself, so it's a lot harder to troubleshoot. So I like to get this just as far as I can until I can flash it, and then test the flash. And if the flash is good, then I know that chances are we're going to have a successful build. If it doesn't flash, then I can figure out why it doesn't flash. Generally, if it doesn't flash, it's a solder connection that didn't get properly connected. Generally, for me, it's been primarily on the USB controller. I do, though, have a box of probably 15 to 20 of these that have various issues that I haven't been able to figure out yet. A lot of the problems I've been able to figure out, but there's a couple that just don't work, and they should. You know, I've got one that it works fine if it's powered via USB, but it's getting overvoltage if it's powered by SIO, so I don't get that one. Talked to Mozilla a couple times on that, and he can't seem to understand what would be causing that. It's really kind of bizarre. Like I said, it's got exactly the correct voltage when it's plugged into the back of the Atari computer and the USB cord is powering it. If I take the USB cord out and just let it get power from the SIO, it's overpowered. It's like 5.5 volts and it will not work. It's kind of bizarre. But those are ones, you know, at some point when I'm not super swamped, I'll take an afternoon and see if we can figure out what it is that's causing those issues. But I've been so busy having to build these things that I haven't had time to go and troubleshoot those. I just put them in a box and we'll come back to them down the road. Worst comes to worst, if I can't get it working, I'll rip the ESP32 off of it and repurpose it, since that's the most expensive component on these things other than the actual SIO plug-in socket. Believe it or not, the SIO plug-in socket is the most expensive. It's the most labor intensive, And the little pins that go in there are ridiculously expensive. So it's like $5 per connection, or for the pair worth of parts. And then don't even get me started on the amount of time it takes to make the thing, because it is a long process. You'll see that's coming up here after we flash it. We do the SIO connections. It's quite a lengthy process. And an expensive one. Like I said, those little pins, you wouldn't think they'd be that expensive, but they're like 15, 16 cents a piece. And there's, what, 13 of them on each, or excuse me, 15 on each one? 13, I was right the first time. So when you multiply that times 26, is what you need for both the socket and the plug, it's kind of expensive. I tend to be extra cautious when I'm building. I don't want to break a pin either. As like I said, I don't like wasting the money. But yeah, with these boards, if they're bad, like I said, the only thing I will preserve would be the switches, because they're easy to remove, and the ESP32, because it's pricey. The rest of the components, it's not worth the hassle. You know, when I got the pick and place machine, I started buying all the passives by 10,000 quantity spool, and it's just amazing how cheap it is to buy those at that quantity. You know, about 100,000 passive components, and it was, you know, $200. Amazes me that they make any money on those at that price. But like I was saying, in the LCD part, when you buy just enough parts to make one or two of these things, and then you're doing it by hand, and you shoot the part out of the tweezer, and you can't build it because you don't have the part anymore. You kind of don't worry about that when you've got spools of 10,000 each of the capacitors and resistors, and you know, the pick and place machine inherently spits parts. I think I was reading somewhere that it said get 10 to 25% more than what you actually need if you're using a pick and place machine, because that's how many you're going to get shot out of it and lost. So this will be the last one. Like I said, we'll get the switches on here, and then next we will flash them, and hopefully they all flash correctly, and we can move on to the next step. I really don't know why this is so satisfying. And yes, before you say it, I know I should have some kind of fan or something. I always feel it the next day when I've done a big batch from breathing all the solder fumes. But what can I say? I'm old school and stubborn. So there you have it. The through holes are all in there, minus the JTAG and the SIO connections. But we've got the switches now, the power switch, all the passive components, the microcontroller, the LEDs, and we are ready to take these over and flash them. So that'll be next up. Hey guys, well that's it for part 3. Looks like we're gonna have at least 4 parts, maybe 5 parts in this series. I'm trying to keep them down to 15 minutes or less. I don't want to bore you too much with too much in one video, but in this last video we got the through-hole components all mounted. In the next video we're going to do some testing and then mounting of the SIO plug and socket, and possibly finishing it. We'll see how it goes. But I hope you enjoyed these videos, kind of giving you an insight on what it takes to put a FujiNet device together. And I hope you like and subscribe, and let me know in the comments below if there's anything else you'd like to see me do. Thanks. Say bye, Bill.